So let's finish up question number 14. I was sort of rushing through that, so I thought I would make another video where we explain this in a bit more detail. So to return to this problem, we did an exponential regression for this data, and my initial point is at time 0 and initial amount 1 unit. Now I'm using 0 and 1 because, well, we always start at time 0 for this sort of problem, and since no initial amount is stated, we can assume 1 is our initial amount. And then half-life is given, so that means after 37.22 days we'll have half of what we began with, and since we began with 1, then we'll have 1/2 of that. Okay, so that's my data, and I then did the exponential regression with that data. And there it is. Now, the point of me doing this is because I'm trying to get the daily decay rate, and so in order to get the rate, I have to get some more information about my model. And so one way to do this is just to get the model and then take the factor from the model and get the rate from that factor. So here's my factor, 0.98154, etc., all that. And to recover the rate from the factor, I've, as you can see, written right here. Oh, and I should be specific about this. This is the growth rate is b minus 1. If I wanted to get the directly get the decay rate, I would do 1 minus b. It's fine for you to do that either way. I'm just going to, because I always forget, I'm just going to find the growth rate first and then change the sign, since I know it is a daily decay rate that I'm looking for. So to call it b, I go to vars, statistics, equation, and then b. And then I'm going to subtract 1 from that. And as expected, that gives me a negative number. So negative 1.85% is my growth rate. So my decay rate in percent form is 1.85%. Okay, and so that's question 14, and that's the last question on the Unit 2 practice problem set.